Hi everyone, I'm Nirisha, Assistant Professor in the Department of CSIT working in MLR Institutions of Technology. Today in this lecture, we are going to see about the passing structures to functions. So how we are going to pass that structures to a functions. So the overview of this is we are passing individual member of a structure and also we are passing entire structure and also we can pass address of the structure. So by using these three ways, we can pass structures to a functions. So we have seen variables passing to a function, arrays passing to a function. Now we are going to say about the structures passing to a function. So here in the first one is individual members of a structure. So to a function, we can also pass individual members. We can also pass the complete entire structure. And also we can pass the structure by using its addresses, which means call by reference. So here the example, see we are taking one example as we are considering in structure, we are considering as a point. To a point will have an x coordinate and y coordinate. So this is a header file and this is a function declaration. Void is my return data type, display is my function name and integer values I am passing to this display function. Those integer values are the members of the structure. So see here struct point. So struct is the keyword that we are using and point is the structure name. So this is the int x one variable and int y one variable. So the first member is the x coordinate and the second member is the y coordinate. So these two values individually we are passing into this functions. And the next inside the main function we have created the variable to this structure type and also we have initialized the values as 4 and 6. It will take the values in a sequence order. So the 4 will be assigned to the x coordinate and 6 will be assigned to the y coordinate to that particular point. And the next we are calling this display function. To this display function we are passing p dot x and p dot y. So p dot x value is 4, p dot y value is 6. So these two values we are passing to the function. So whenever function call happens, it will come to the function definition. So the p dot x will be copied to A and p dot y will be copied to B. So as we know, this is an actual parameters and these are the formal parameters. So void displays my function name int A and int B. P dot x will be copied to A and p dot y will be copied to B. And by using this printf statement, we are printing this A and B values because the x value, whatever the x coordinate that we have, that is copied to this A. So in this function, we can access that by using the A variable and B variable, those x and y coordinates. So if you run this program, you can find here, see the x coordinate is 4 and the y coordinate is 6. The values of x and y coordinates are 4 and 6. So in this way, we can pass individual data members, individual structure members to a function. If you have an only requirement of passing only one member, then one member also you can pass. For suppose, if you want to edit someone's student marks, so that particular student record, in that particular student record, you can pass that particular marks to a function so that you can change by using that user defined function. That marks can be changed. So the student structure, employee structure, whatever the structure is, all the structures we can pass to that function. Individual members also we can pass. The next one is the passing entire structure. The complete structure we need to pass to that function. So here the same example I have taken, the point example. So this is a header file and these are the structure declaration and this is a function name. Display is my function name, void is my return data type and struct point. To this display function I am passing the structure type. So the struct point, the structure I am passing to this function. So that is the reason why I have declared here the data type of that structure. And also if you want to initialize a variable, then you can also declare a variable over here. So if you mention the data type in the parameters, that is enough to a function. So int main and we have declaring this variable and also giving values to that particular variable. And to this display function, we are calling this P. P is nothing but the variable. Structure variable directly we are passing. So if you pass the structure variable, how many members are there in the structure, that complete members will be passed to the functions. So this again same display function. So the point P will be copied to this P1. So p dot x value will be copied to p1 dot x and p dot y value will be copied to p1 dot y. So this P is, you can find here, P is a variable of structure point. So this P is a variable of structure. So by using P we can access X and value, and by using P1 also we can access the X and Y values, the members that are present inside that structure. And then next, by using printf statement, we are printing the X coordinate. So P1 dot X. So here we are using the P1 dot X because the complete structure we have passed here. So with the help of the structure variable only we can access the structure members that we know we have seen in the previous lecture. So the P1 dot X value will be reflected on the control string, and P1 dot Y will be reflected on the second control string. So coming to the test cases, you can find X coordinate is 4 and Y coordinate is 6. And one more example, passing the entire structure. So program to add two complex numbers using structures and functions. So we need to add some two complex numbers. So that two complex numbers we are placing inside the structures, and that structure we are passing to the function. So here this is a header file and this is the struct complex. The complex is my name of the structure. Struct is a keyword. So here we are using two data types, that is two members, that is real and imaginary. For a complex number, we'll have real part and imaginary part. The complex number will be in the form of A plus BI. So this A is the real part and B is the imaginary part. So here this is the structure declaration. Struct complex is my data type, and add is my function name, and struct complex X and struct complex Y. So the data type here that we are passing the structure data type. So that is the reason why we have mentioned struct complex as the data type, and also we have created the variable of the structure type, that is X, and here also we have created the variable of structure type, that is Y. And here inside the main function we have created A, B and some variables of structure type, struct complex type. So by using these variables A, B, sum, we can access the members that are present in the structure. And we are asking to print the complex number, first complex number. So we are reading by using complex number, and where we are storing in the A dot real and A dot imaginary. So suppose here we are asking to enter complex number 3 and 5. So here 3 plus 5i will be my first complex number. And the next we are asking to enter the next second complex number, and by using scanf statement we are reading and we are storing in B dot real and B dot imaginary. So here the second complex number we are giving here it has 6 and 7. So it will be in the form of 6 plus 7i. And by using this printf statement, we are printing that in the form of a complex number. See, you can find here A is equals to percentile D plus percentile I, which means A is equals to 3 plus 5i. And the next B is equals to B dot real, comma, B dot imaginary. So these values will be reflected in first control string, and this value will be reflected in second control string. So this is the A value, and we have given here 6 and 7. So B is equals to, in real part 6 value will be stored, and in the imaginary part 7 value will be stored. So we are printing that A and B complex number values in the format. And the next we are calling this add function. So whenever we call this add function, it will return to the function definition. So this A is nothing but the variable that we have created for the structure type, and B also the variable that we have created for the structure type. So this A will be copied to this X, and B will be copied to this Y. So which means A dot real and A dot imaginary will be copied to the X dot real and X dot imaginary. And A, B dot real and B dot imaginary will be copied to the Y dot real and Y dot imaginary. So here X dot real is equals to A dot real. Here A dot real is 3. And X dot imaginary is equals to 5. And Y dot real is equals to 6. And X dot real is equals to 7. So these are nothing but the variables that we have created of this structure type. So by using the variables, we can access this particular structure members. So whatever the A value we have, the A variable value we have, that value will be copied to this X. Just now we have seen in the previous example. While we are passing the entire structure, we can access that all the members of the structures in the user defined function E. And here we have created one more variable that is of structure type, that is result. So res dot real is equals to x dot real plus y dot real. So the addition of these complex numbers will be 3 plus, we are going to add the real parts and we are going to add the imaginary parts of the two numbers. So these two are the real parts and these two are the imaginary parts. So here the real part is 6 plus 3, that is 9, and imaginary part is 12i. So this is the actual answer for adding the two complex numbers. So here we are taking the real part of first complex number and imagine a real part of second complex number. Real part of first complex number and real part of the second complex number. So the real part of first complex number is x dot real and real part of second complex number is y dot real. So here x dot real plus y dot real we are adding by using this plus sign, and that we are assigning to the result dot real. So now result dot real will be is equals to 9. So x dot real value is 3, y dot real value is 6. So 3 plus 6 will be equals to 9. And the next we have result dot imaginary. So result dot imaginary is equals to x dot imaginary, and x dot imaginary is 5. And sorry, this is y dot imaginary. X dot imaginary is 5 and y dot imaginary is 7. So 5 plus 7 will be is equals to 12. So this, by using this return, we are returning the structure variable result. So this value will be returned to the main function, and that value will be assigned to this sum variable. So here the sum also we have created in the structure type. So now this sum dot real will be equals to 9 and sum dot imaginary will be is equals to 12. And then by using this printf statement, we are printing sum is equals to sum dot real will be in say first control string, and sum dot imaginary will be placed in the second control string. So by using this printf statement, we'll get the sum as 9 plus 12i. So we can also multiply the two complex numbers. We can also subtract the two complex numbers by passing the structures to the functions. The next one we are going to say about how we are going to pass the address of a structure to a function. So how we are going to pass address of a structure to a function. So for that we are taking one header file, and the next this is the structure variable, and the next same structure structure example we are going to take, and a display and the structure point and one pointer variable here we have, which means now the structure point will have a pointer variable. So here we are declaring one variable to this structure variable p is equals to 4, x, and to this display function, instead of passing this p or something else, some individual data types, what you're passing, we're passing the address of p. So if you're passing that address of p, that address of p will be stored in this p1. So as we know about the pointer variables, the pointer variables will hold the address of the another variable of similar data type. So this is a pointer variable, p1 is a pointer variable, and here we have p. P is of a structure variable. So this pointer variable will hold the address of the another variable, that is p. P1 is holding the address of the p, and that two variable data types are the same. It is of structure type. So it is possible to hold the address of p in the p1. And by using this printf statement, we are printing the x coordinate, and by using this printf statement, we are printing the y coordinate. And here one more point to remember here, it is while using this pointers concept, we have used a star to get the value that is present inside this address, asterisk operator. But in the structure concept, we can also use star, and also we can use the arrow symbol. So this arrow symbol will be very easy to use it than the asterisk symbol. So this p1 is pointing to the x value and p1 is pointing to the y value. So that x and y value will be printed over in the test cases. Thank you.